Hi, welcome to my Tidy Tuesday screencast. I thought we would start off just by going over the data set that I chose. It's over solar eclipses for 2024 and 2023. There's four different data frames that we have. Um, we have an annular, a total, and two partials. I think my big takeaway, just looking at the data set, when I first started looking at it, is that all of our column names for each data frame are the same. So that will probably cause a little confusion. It might just take a little extra work to make sure that we always know what we're looking at. But we basically, for the two partials, we have eclipse 1 is when we start the eclipse, and then our last column is always going to be when we end the eclipse. And then our middle column is always going to be the time when they reach the maximum uh eclipse, I guess. And then for the ones where we actually experience totality or annular, if we experience the totality, because annular just means that the moon was on the wrong axis, and if it had been at a different degree on the axis, we would experience totality. So um our columns 3 and 4 basically just say that between this time is when we were experiencing totality. Um, so yeah, let's jump into it. Let me switch screens here. If I can. Sorry. Okay, here we go. So I just set this up. These are some of the topics that I want to explore as we look through it. And the first one, I think I want to do some visualization of the totality for our 2024 total solar eclipse. Um, oh, sorry, the second one. Okay, I apologize. I misspoke. Our first topic is going to be finding the average totality duration for the 2024 total solar eclipse by state, and then we're going to use some of that in our second topic too. Yeesh. Okay, so to start off, let me get in everything we need. So this is just pulling in the data for that week for the data set that I chose. These are our four data frames that we're going to need, and I'm pretty sure these are the only libraries I'm going to need. I could be wrong, but I think that's it. Okay, we don't need that anymore. So for the first one, looking at at the total eclipse. Basically, what I think I'm going to need to do is that this is the hours, this is the hour of the day, minute, second, which is pretty straightforward to work with. And so this is the end of the eclipse, and this is the beginning of the eclipse. So if we want to find the total, if we were finding the total eclipse time, it would just be 6 minus 1 for the columns, but we're looking for totality, which we know is this column and this column, the beginning and the end of the totality. So I think what we're going to want to do to find that duration of totality is just subtract those two columns for each other. So I think I'm just going to, uh, let's just deciding if I want to create a new data frame or just manipulate the one as it is. Um, we'll just do it as is. So I am going to be using dplyr first with the pipes here. So it makes my life easy. And I think we're going to just need a mutate statement because we're creating a new column. So let's just call it totality. And then we need this column minus this column. Okay. Okay. And then, yeah, let's see how that looks. Okay. So there we have it. We have it in seconds. I think though, so we're looking for, so that has the duration for each individual state and a city, which is what the name column represents. These are just all, I believe they're cities, they might be towns, I'm actually not sure, but all separate places. So what we're looking for is we're going to end up having to group by state, and then we're going to want to find the average within each state. So I believe we're going to need, I think we're going to need totality to be in numeric, so I can just continue the mutate statement, and then we'll do as numeric. Oops. Yeah, okay. Okay, I think that looks good. And yeah, okay. So that is numeric now, which is good. So yeah, I said before we're going to need a group by state, and then I think we can just mutate another column for the average. Yeah, I think we can just do that. So I'm just gonna, well, I can just continue this one actually. So we're gonna group by state. And then we'll have to do another mutate statement. And so let's call it uh average totality. And is there an average function? Let's see. Okay, no, there's no average function. Uh, might be, I think it's mean, actually. Yes, okay, that was it. That looks pretty good, which is not super nice to look at, just because if you want to see the average of anything else, you'd have to go down. We could probably make a summary of that to make that a little easier to look at. So yeah, I guess so if we just want to look at the average by state, we don't really need anything else. What we would just need state, and we would want like one row, like we'd want, is this Arkansas? Yes. We want Arkansas, and I think Alabama's next. Oh wait, no. Alabama, okay, Alabama must not be in this data set for what states saw the eclipse, but it'd go alphabetically. We'd have one state per row, and then the average. I think, and yeah, we can include we wouldn't include the name because we just want state and average. So I think we're just gonna want to use the summarize function. So let's do that. I'm gonna go ahead and just do a new one here in case this doesn't work out. Okay, so we're gonna want to group by state again. And then I want to call the same thing. And that's gonna equal, well, I guess it would just be the same thing. So I guess basically what I'm doing, I could just replace this with this, and I think that would be a lot cleaner. It might, let's see how this runs. State not found. Oh, that's why. Okay, what is that? Okay, yep. That looks good. And so here are all the states that are in our data set, because these are the only ones that saw this particular eclipse, which I guess Nebraska wasn't. Oh, yeah, I guess Nebraska wasn't included in this because we didn't experience totality, so they're only including states that experience some sort of totality. And yeah, that looks pretty good. I'm happy with that. I guess to clean this up a little bit, I would basically just I don't need this. I guess I'll just replace this. And yeah, that's everything I needed. Okay, the second one now. I got ahead of myself earlier. This one I wanted to basically what we're seeing here, I wanted to visualize this in sort of a like on a continuous scale where we use color to kind of visualize what we're looking at. I do have a little drawing of it. I need to switch my screen again real quick. All right, here it is. I know it's not great, but I am also not sure if this is what the path looked exactly like, but I thought this is kind of what it was. So basically what we would see is those numbers would be a scale here. I think it'd probably be like maybe 200 seconds. Is this? Yeah, this is in seconds. That seems short. Is that right? Is this minute? There's no way that's minutes though. Well, okay, let's take a look. Let me go back. Let me look back at the original data real quick. Yes. Yes, that is in seconds. Okay. So we know that our average in seconds, it'd probably be about 200 seconds. Sorry, I didn't switch my screen back, so you didn't see me looking back at the original data. You probably just saw my mouse moving around, but yeah, sorry. So this would probably be from like 200 seconds, and I think it's down to like 80, something like that. And then the people who saw, or the states that saw a higher number of totality would have a darker color. And then we would kind of see it expand from that. That's kind of what the vision is right now. So let me switch my screen back and then I'll start working on that. All right. So what are we gonna need? We're definitely gonna need maps are not always my friend. I think, okay, I have I had this code from before because this is way back on the homework that we did where we did maps. This is data that Dr. Vanderplas, or this is code that Dr. Vanderplas provided with to make a basic map, like the data that has the longitude and latitude that will create a map for you. And then I just want the US region. So that's what I'm putting in. And then I think it's just USA. Okay. Yeah, okay. I think that's all I needed. Okay. So I know to make a map, we're gonna need we're gonna need geom polygon, we're gonna need geom point, and then we'll probably have to mess around with the coordinates a little bit just to make sure it looks good and we can actually see everything that we need. So we're working with the same eclipse, the same total 2024 eclipse. So I think I actually just am gonna pull back this column and I'm gonna use that again because for the geom point, I think that average is what I'm gonna need to be graphing. So I'm gonna run this again and use this. Wait, I might not need the summary for this one though. Uh, okay, well, we'll just find out. I think this part is all I need because I'm pretty sure I'm gonna want all of those cities because when we're looking back on our original data, we need the latitude and longitude to point. So I'm pretty sure that's what I'm gonna need. If it looks crazy, I'll go back and worry about it, but I know that I'm gonna need that. We're gonna need geom polygon, which we're gonna use the map variable that I just created. We're also gonna need point. And then, yeah, we'll have to, I'll see what kind of coordinates I need. It's gonna be Cartesian, but I'll see how much I need to change it once I look at what the map turns out to be like. Okay, so for aesthetic for the map polygon, this is just gonna need to be longitude and latitude. Latitude. And then we're gonna need to group. I think it's one of these two. I think we need a group by group, if I remember correctly. I think that's what we did last time we were making maps, which is kind of what I'm basing this on. And then let's see what that looks like. And then here, we'll just need that. This will also be longitude and latitude because this is putting our data points on the map. And so that will be lat and long. And then so for the legend, the color, I think that's gonna need to be let me run this real quick. So I think it's I think it's just gonna be totality. Okay. We'll definitely need to add more, but let's just see if this works. All right, never mind. Okay. Okay. Can't add ggplot to a ggplot object. Okay. So I know, well, I'm not really sure what about it. No, that's not right. I think to place the map, I'm gonna need a color. I don't think I need the coordinates. I could. I didn't think I would have needed them though. Is it this? I didn't think that mattered. Okay. Okay, something there mattered. Yeah, so okay, well, that looks promising. That kind of looks like an eclipse path. Okay, let's I guess I want this to be different then. I think I might actually want that to be white. But I need the well. Oh, so okay, so that's the outline. The color's the outline. My bad. Is it fill? I think that's right. Yeah. Okay. Okay, let's figure out the Cartesian now. So yes, that's what we want. So we don't really need Alaska in this. We could cut that off. But let's just do the x-axis first. So on the left-hand side, yeah, I think I'm just gonna do only where we have data points. So I think I'll just start at like 50, -50 to oh wait, -50 would be over here. Okay, sorry. That should be like 150 to -50. And let's see what that looks like. Okay, yeah, that looks good. I still want to zoom in a little bit more just so we can see this a little bit better. So I guess I'm just gonna fine tune this a little bit more. We can do like 130. or yeah, we'll like 130 to do 60. And then I think that's just gonna spread it out too much. I think I'm gonna need to change the Y axis as well. Yeah, yeah. All right. Let's change Y. Oh, it's excellent. So let's do, I think it goes up to down. So let's do 25 to 55. See how that works? Yeah. Yeah, that looks pretty good. That I like, you can really see the points. I think I can make the points a little bit bigger. I wonder what that would look like. I didn't know. I'm not sure if that made that much of a difference. And yeah, that's definitely a little too big. All right, yeah, that looks pretty good. I feel like so there's definitely kind of overlay on them, which I'm not really sure how I could fix that, but I like how that looks. I'm pretty happy with that. I could zoom in a little bit more, I feel like, to see the points a little bit better. Let's go like 45. Um, to 20, and then we can do 25 to 55. I know this is a little nitpicky at this point. Oh, that is definitely not what I wanted. Okay. Oh, that's why. Whoops. That's definitely also not what I wanted. What did I? Okay. All right. I'm just gonna go back. I regret changing that. All right. I'm just gonna leave it there. We can add some titles and stuff. Let's call it totality duration of 2024. And then our x-axis, I think I'm just going to leave the label blank because it's, well, let's put in, if I can spell it right, and then it needs to be in quotations. Did I spell solar wrong? Okay, never mind. Okay. See a little bit of Alaska there. I'm actually, that kind of bothers me, so I'm gonna take that off. Ah, much better. This definitely looks a little warped, but it's okay. I am happy with that. I'm happy that that it's a tangible result. I mean, that looks right. We have the lighter on the inside, which would be, it's the opposite of what I drew, but I had darker on the inside, but we have lighter, which indicates longer duration up to 250 seconds, and then the darker is the lower amount of duration for the totality. So yeah, I think that is good. I'm happy with that. I think we can move on to the next one. So for the next thing, I wanted to create a summary of the two partial eclipses seen in Missouri. So that's going to be these two here. So we know that we have the same amount of columns, which definitely makes it easier. If I had tried to, I think if I had tried to work with total and partial or annular and partial, that would have been a little more difficult because the way they measure the time is a little bit different. Don't need that anymore. So I think the first thing that we're gonna do is we're gonna want to find a way to get our data together so that we can have one summary in the end. I am kind of thinking that there might need to be some work done before we just join it together, but I just want to see what it looks like. You need partials. Sorry if you can hear anything in the background. Okay. So we have a many-to-many relationship between X and Y. And then, okay. So I'm guessing that this is because there are two different eclipses. So there are probably cities and towns that only saw one but not the other. So we don't have a name match for everything. And then I think this is probably happening. I'm guessing. Well, I guess let's take a look. I'm thinking that this is going to be because we have town names. Okay, yeah. So Abbeville looks like it's a city in both Alaska and Georgia. That's Georgia, right? So that's not right. It's Alabama. I'm sorry. I think that's Alabama. But yeah, okay. The point is we have cities or names of cities that exist in multiple states. So that's not ideal. Um, I think that oh wait, sorry, I forgot. We're just gonna do Missouri. Okay. Well, I'm gonna filter out. I'm gonna delete this. So I'm gonna filter out so we only have Missouri data for the two partial eclipses, and then we'll go from there. So I think I'm gonna just create a new data frame while we're working with the Missouri data. So I'll just call it M23, Missouri 2023 eclipse. So it's gonna be from this, and then we're gonna want to filter state. Okay. And then yeah, let's just see how much we have there. Okay. Let's do the same for the other one. Okay, and they're pretty close in observations, but I'm guessing there's probably gonna be a couple cities that only saw one or the other and not both. So hopefully there's not too much of an issue there. I think if I join them, it'll just ignore that. I don't think it'll join anything together that shouldn't be there. Hopefully. Okay, so for a summary, I think since I'm just making a summary, I think I'm definitely gonna want our I mean, I guess we could show duration of the entire eclipse. I think that would be something good to have on there. We can kind of see how long each eclipse was. So yeah, I'll do that here. So it's gonna be another mutate statement. It's gonna be pretty similar to what I did in the first one. It's gonna be very similar to this, but instead of I'm just here, I was finding the length of the totality. Instead, I want to just find the total ugh, the total duration for each eclipse. So I will just call it duration. And then it's gonna be eclipse 5 minus eclipse 1. Oops. Geez. Okay. Sorry. And then I think I know I'm gonna want to add numeric, so I'll just do that now to make my life easy. Okay, so that looks pretty good. And I'm guessing this is in seconds again. So maybe we'll change that to minutes later for the sake of ease of reading it, I guess. I'm just gonna do the same thing for the other one. Oops. All right. Oh yeah, so right off the bat, it looks like the 2024 one was a little shorter just because it's all 8,000 seconds. This one we have 9,000. So I guess that answers my question there. But I think now, if we want to put them together, I think for the sake of ease, I think I'm just gonna take only the name and only the duration, and I think I'm gonna join those together. I don't think I'm gonna use any of the other times. If I wanted to do anything else with time, I can add another column in, but I think for joining them together, I think it'll be a little easier this way. So let's just take name and duration. Oops. Yep, so that looks pretty good. And then we'll join them together. And so, I mean, just looking at, sorry, so just looking at our top 20 names, all of these were the same. So hopefully we're not having, because I'm probably going to get the error of the one-to-one X to Y relationship is too many, but I don't think it's going to cause too many issues. I think we have a lot of really similar cities. I don't know if I was better at this, I probably would figure out how to keep that from happening, but oh well. So I'll do call partial Missouri. And then I'm gonna want to join by name. Yep, that's what I expected, but oh, okay, hang on a second. I'm gonna go back and I'm gonna rename these so that the duration has unique column name because I don't really like looking at the X and Y. I rather just know where it's supposed to be or what column it's or what data frame is from. Sorry. Okay, there's all of them. Nice. That looks pretty good. So I think I said it before, I think I'm gonna change these to minutes. So we can read it a little bit easier. So we could uh we could just divide these columns by 60. I know there's some lubridate functions I can use though. I think I'm gonna try that first. So I'll just start fresh. Okay. So I know that there's a function called seconds to period. I might need to look this up. I'm not really 100% sure. So duration. Well, hang on. Actually, I'm just gonna I'm gonna do this on our joined column, on our joined data frame instead. I'm not gonna do it individually. Ugh. Okay. Oh, I just might. I think I might need to use a mutate statement to do this. Maybe. Okay. So duration 3 seconds. It's a period. Okay, no error. Well, uh, okay. So that is not what we want. That, okay, I think it assumed that the number I had here was minutes. And so it converted this to hour because this should be minutes, this should be seconds, I think. I'm not really sure actually. Let me do some quick math real quick. So let me run this again. So we have 9,680 seconds divided by 60. So that's 161 minutes divided by 60 again is about 2 hours. Actually, that does look right. Okay, so this is correct. It's not really one I wanted. I wanted it in minutes. So I wanted to see that 161 minutes. But I like this as well. I think this actually is good. I'm gonna keep this because I feel like in general, this is easier to read to like an average viewer just looking at a data set than it would be to just look at seconds or minutes. So I think I still want to try to figure out how to do it in minutes, but I like how that turned out more, I think. Because if I divided it by 60 twice, that would just give me a, a decimal number. And this actually gives you the labels and it looks a lot better. That's exciting. I wasn't really expecting that to work. Let me get the other one in there then. Well, actually, let me just see what else I could have done with our other duration. So we could have done divided by 60. I think that's all. I think that's do that. Yeah. And then can we divide by 60 twice? Maybe? Well, actually, I don't think that was what I wanted to do. Um, oh, I do not need another mutate statement here. Okay, that looks a lot better. But I think I'm gonna sorry. Okay. I think I can just do this again and it'll divide it by twice. Divided by 60 twice, I mean. Uh, actually, well, okay, I see what happened. So I never reset this column to the original number of seconds, so it just kept on dividing. Okay, hang on. Let me just rerun the whole thing. That looks about a lot better. Well, okay, this would be an hour number then. So yeah, we have 2 hours, and I think that would be so it would not be 49 minutes. It would be 30 minutes because we're looking at a decimal, not in which is, I guess that's another reason why it's a little confusing to look at time in this sort of format. So yeah, I'm gonna go ahead and just change it back and do what I originally did. Oops. So I'll just do the same exact thing. And there we go. That looks pretty good. And yeah, so we can see the 2023 eclipse was pretty consistently longer pretty much everywhere that it was seen. I'm sure that there's a way that I could figure out if there's any place where it wasn't longer, but I'm not going to do that. All right, so I'm pretty happy with how that turned out. Yeah, I think that looks good. I think that's really readable. So I'm gonna move on to my next topic then. Okay. And I don't know. Maybe if I have time, I can come back and try to figure out how to fix that error. So my fourth topic, I wanted to look back on these two partial eclipses and I wanted to compare them with a line graph, I think is what it's going to look best. Let me switch my screen again real quick. I did draw out what I wanted it to look like. Oh, whoops, wrong one. Scroll down. Yeah, so what I'm thinking we're going to want to see is that we'll have the city names here, and then we'll have the length of duration. So I've already found that for my partial eclipses in Missouri, I would just have to take away the filter because I'm not specifying this to Missouri. I want to look at all of our data for our partial eclipses, and then we'll go by seconds, I think. And then so our year will be like this. And then that's just an estimate, whatever. I'm not really sure what it's going to look like. And I'm pretty sure this is what we're going to want our data to be looking like, I think. So we're going to want to have our start time, end time. I guess we don't really need these when we're graphing, but we're going to want the total duration for every single city that we have. So we're going to want to, I'm going to, oh, whoops. Sorry, I accidentally clicked the X button on my screen sharing. So I apologize. I'm back. Okay. So I was about to say what I wanted to do is I want to join my two partial data my two data frames of the partial eclipses, but I want to do it a little differently this time because I had another idea and I think this other way might actually be a little bit easier for what I need. So what I'm gonna do, basically, I'm gonna do the same thing as I did before, and I'll just call it partial again. Partial eclipse. Okay, and then by name again. So again, the error we were having the first time is because we have states, or we have cities that have the same name in multiple states. So when they're joining, they're going to the wrong place. So what I think I want to do is I'm going to make a key, like a new column that's a key to um so it's like I can join them together. Sorry, I'm not sure if that is making sense. I'm going to make a common column in each of them so that I can join them together and they're going to be like matched correctly together in the join data frame. Okay. And think I think the easiest, well, actually, I think the easiest way to do this, I think I might just parse these two together because then we have the name and the state assigned to it. So yeah, I think that's what I'm gonna do. So we're gonna make a new column with the mutate statement, and then I'll just call it state name, and no, paste them together. State name. That looks pretty good. And I'm going to do the exact same thing for the other one. So now we have a state name column in each of our data frames. So I can join them together, and I believe that we should see things be correct now. Oh, that's why. Okay, this is still really messy, but now, did we still get the error? Okay, we still got the error, but it looks right in the data frame, and that's what I was going for. So that's a good step. Actually, I'm just gonna Google this super quick so I can figure out what this is. All right, whatever. I think my screencast is getting a little long anyways, so I'm not gonna worry about it. I want to get this visualization done. Okay. So I think the next thing I'm gonna want to do, I'm gonna want to make duration columns again because that's what we need to actually graph it. So I think I'm just gonna use some of the code that I've already written. It's already right there, you know. I think this is what we're gonna need. So let's partial. But then these now, since these names are duplicates, see, this is what I mentioned early in the screencast where these have the same name. So I know X is going to be the 2023 and Y is going to be the 2024. And if I had more time, I'd just rename all of these to make it a little easier to look at. But I'm not going to do that. So what we're going to want is just to add the right. And I'm not sure. I'll keep the numeric. I'm not really sure if that's what I need right now, but and then yeah, we'll add this. Why is that? Okay. See how that looks. Okay. Why is one of those not numeric? Because I didn't change it. Okay. That looks correct now. That is different though. Oh, okay. What I originally thought is that this number looked different than what we were doing when I was working with the Missouri data, but this is the not from Missouri. That's why. All right. So I think the next thing that we're going to want to do, I think I'm going to do a select statement and only get the stuff that I need for the graph. Well, I can just add it onto this one up here. So what are we gonna want? We're definitely gonna want state name. We're gonna want this. I know I drew it out where in when I had that picture, I drew it out so that I had some of the date time columns with the times in it, but I'm not sure if I really need that for the graph, so I think I'm just gonna skip that and I'm just gonna do these three. Oops. And then next, I think what I'm gonna actually need to do is I'm gonna need to pivot the data. Well, let me run this real quick. Let me just see what we have. Okay. So this is what we're working with. And I think in order to graph this, I'm gonna, yeah, because I want these to be in the same column for each state name so that I can have when I'm graphing the geom line, I can have like color equals duration and then, or a year, I guess technically is what we'd be, is what the different color would be representing the 2023 versus 2024. So let's do that. So for pivot longer, we're gonna want, I think names to, we're gonna want names to, I'll call it year for that. And then values to duration. Let me see what that looks like. Okay. Oh, okay. I need this. So I'll do, yeah, I just need to list these basically. Okay. That looks like it's supposed to, I believe. Does that need I think that needs a comma there. And yeah, okay. Nope, apparently not. I think I don't need that. Okay. Yes, this is what I wanted. This preferably would just say 2023, 2024. I think I can I will just go back and change that then. Well, it might give me issues because it's listed as a number. But we'll see. That's supposed to be a 3. And then this would be 23. This would be 24. Okay. And no, it does not like that. So I'll leave it as that. That's fine. Okay. So we have this. Let's go ahead and tackle the graph now, I think. So we're going to want partial. And then our X would be state name. Yeah, that's what we'll want. Which I guess we could also make this look a little different where we had like a comma state so that it actually read a little bit more like how it would typically be listed, where we say city state. But also not going to do that. Y is going to be duration for this, which we have in seconds. I'm just going to leave it in seconds for now. I think that might be a little easier. And then we're going to want the color to be year. I think we also need a group. Okay, that looks good. And then we're going to want G on line. And then, yeah, we could get into labs and stuff. And let's just see what this looks like. It's a lot of data. So I don't think this is going to look very well. All right. So this is our x-axis is definitely not ideal. I think we can rotate, well, okay, I think we can rotate them, but based on what this looks like, I'm not sure it's going to matter. We have 57,000 observations. Um, so I don't think that's going to matter a whole lot. That's definitely a problem. I'm not really sure. Well, do this. So our title would be, let's do 2023 oops, versus 2024 eclipse, partial eclipse, duration. X would be, I think I would just call it state and then name. If I had it formatted differently, maybe I would do it differently, but um, and then let's do X is duration, and then let's clarify in seconds. I'm not really sure I want to run this again, to be honest. Let's see. Yeah. Well, I think we could summarize the data by state and then plot the average duration instead of the duration for every city. We could also, I think we could also, is it facet wrap per state? So we could just do individual state. I think I'm running a little too long for the screencast, so I think I just put it there. Um, yeah, this is pretty messy, but I think that would probably be my next step. I think I would probably summarize and then plot an average instead, just so this is a little less crazy. But I'm happy that we got a graph. And yeah, I thank you for watching. And I'm going to end it now. Thank you.